Chapter 2 The Big Bang. The screen you are looking at right now is one possibility of what could have existed moments before our universe was created. Or not. We don't have a clue. To be completely honest, we humans still don't know anything about what happened before our universe existed, and we might never know. The closer we get to the beginning, the more muddled up our physics and technologies get. Moreover, space-time, which is basically all the universe, breaks down. Consequently, we might also never know why our universe was created. All we know for sure is that it was created, somehow, and provided us with all the raw materials we use today. As for how the universe was created, the prevailing theory is the Big Bang. Now, before we go on, let's address the elephant in the room. It's a common misconception that just because it's a theory, it's not necessarily true. In everyday language, a theory may be synonymous with a guess. However, in science, much like the theory of gravity, a theory is tested several times, provides explanations for many observations, and is also backed up by a ton of evidence. Basically, theory does not mean a guess. It means based on our best understanding of the world. That is the most probable truth. Think of it as science being humble. Okay, moving on. Ironically, the Big Bang wasn't really a big bang, in the sense it wasn't an explosion inside the universe. It was the moment when space and time were created, and its proceeding expansion. Space being all the atoms that you can interact with, and time the dimension that all the atoms exist inside. Theoretical physicists and many spiritual teachings think of space and time not as two different phenomena, but two expressions of one. And this kinda makes sense. Think about it. If you tell your friend to meet you somewhere, you can't just tell them when or where you want to meet. You must clearly state both. For the meeting to take place successfully, your friend must know the geographical location and the time to convene at the decided location. So, going back to the question, what happened before the universe? At least in terms of our current understanding of space-time, the question is literally impossible to answer because time itself had yet to be created. So asking what happened before is pretty much nonsensical. Wait, what? Precisely. To average people like us, all this makes no sense. We like to think of it as explaining the concept of colour to a blind person, or explaining the taste of water, or explaining the meaning of the word the. Big History Lesson 1. Not knowing is a theme that is going to appear many times in this course. And it's also one that is always going to be present in life, no matter who, when, where, or what you are. There's a common misconception that smart people know a lot. Truth is, they don't know any more than you and I. They just know how to deal with it better. A skill anyone can learn. In life, the quest of trying to know everything, especially before doing anything, is a never-ending battle which nobody can ever win. Focus more on how you react and adapt to not knowing before labeling yourself as not smart or a failure. So far, there are countless big questions that we humans have zero clues about. But we like to believe that we've come pretty far. Likewise, for being successful or simply happy in life, embrace the uncertainty and always keep moving forward. But now, back to our journey. So, how do we know any of this happened? Well, that's kinda the reason we invented science. Especially when talking about objects and events so far in the past, it's very easy to mix up fact from fiction. So we have science to step in to categorize the objective truths from the subjective ones. The tool science uses to accomplish this goal is called math. Math is one of the most versatile tools we have. Literally everything can either be interpreted using numbers or at least be represented using numerical values. In other words, math is the language of the universe. For example, if you had to describe a soccer or football, you could say it's a spherical hollow object of whatever colour made out of synthetic leather. A pretty specific description. However, when it comes to gravity, how could you describe it without being ambiguous? You can say it's an invisible force pulling you to the ground, but without math, you're stuck. Only math will give you an idea of the predictable relationship between mass and gravity. It is the only language that can successfully and elegantly describe the happenings of the universe. Proof of this lies all around. The device you're using, the ability of it to connect to an invisible network, electricity, and countless others are all the fruits of our understanding of math. And math clearly describes an event like the Big Bang. Overall, based on our best knowledge, the Big Bang is the best place to start our story of everything. Great. Now, since that's clear, let's move on. At the moment right after the Big Bang, the universe was smaller than an atom, and in fractions of a second, it inflated to the size of a big avocado. This cosmic inflation is probably one of the most important events of all time. It is so because if it didn't take place at the speed that it did, our universe would look very, very different. The force of gravity would have been so strong that energy and matter, which is really nothing but a condensed form of energy, would be distributed very unevenly. But instead, we got a universe which was vast and uniform everywhere. In addition, when the universe was subatomic in size, there were these quantum fluctuations. This is nothing but a fancy word for tiny, tiny irregularities. And when cosmic inflation took place, these irregularities resulted in small clumps of matter and energy in the mostly empty universe. If none of these pockets existed, nothing would have ever happened, because there would not be enough energy for stars to form, life to emerge, and all the complexity that was to follow. The first law of thermodynamics states, no energy can be created or destroyed. And all of us alive on this planet, the billions that came before us and the billions that will come after, were all conceived at the moment of the Big Bang. We have merely changed form, and will continue to, a lot. We were all the direct result of these tiny irregularities that happened at the birth of the universe. About a billionth of a second after the Big Bang, the universe had expanded to a point where the known fundamental forces emerged: gravity, electromagnetism, and the two nuclear forces. And just like that, physics was created. Around 3 minutes later, the universe cooled down to a point where the first nuclei of the simplest elements formed: hydrogen and helium. Now we have chemistry. Fast forward approximately 400,000 years, the universe cooled to a point that allowed energy and matter to separate. At this point, radiation was finally allowed to freely move through space. Before, the universe was essentially invisible, but now the free radiation produced a bright flash of light, which we know today as the cosmic microwave background radiation, or CBR. You can think of it as the universe's fingerprint. It is everywhere. all static you hear on old school radios and TV signals is around 1% CBR. You can literally hear the universe in its infancy. We know this because light has a speed, and the CBR you hear has been travelling for around 13.8 billion years. This also gives us an idea of the size of our universe. A light year is not a measure of time, but is the distance it takes for light to travel in a year. For reference, it takes less than 1/5 of a second for light to travel around the Earth, and it takes about 8 minutes for light to get to us from the Sun. It is estimated that the observable universe, or the universe that we can see, is about 92 billion light years in diameter, a little bubble. But in actuality, we might never know the true size of the cosmic horizon, the furthest point light has reached since the Big Bang. For all we know, there might be other small bubbles, much like ours, with their own sets of physical laws. Like we said before, all this stuff stops making sense to us as well, but it is what it is. Before we end this section, here's a little fun fact. In 2002, scientists added up all the light of our cosmic bubble and hypothesized that if somehow a human saw our universe from outside the bubble, the color they would see is beige. Yes, the color of our universe is boring beige. Pretty anticlimactic, but they called it cosmic latte. So let's just run with that.